So hi and welcome to your CPE 6101 Computer Engineering as a Discipline. So today our topic is week 4 to 5 Introduction to Engineering Design. So for the course learning outcomes, introduce you to the engineering design process, discuss the basic steps that most engineers follow when designing a product, discuss the importance of considering sustainability in design, introduce important design factors such as economic consideration, material selection, teamwork, project scheduling, engineering standards and codes. So objectives. Okay. The main objective of this lesson is to introduce the steps engineers follow to successfully design products or provide services that we use in our daily everyday lives. So we'll start with the design process basic steps. So step 1, recognizing the need for a product or a service. So based on the image shown, he needs a better roller skates. So instead of using a roller skates, he wants to use a roller blades, which is better in terms of speed and comfortability. Step 2, problem definition and understanding. So this is the most important step in any design process. So before you move on to the next step, okay, so how you have to make sure you understand the problem, make sure that the problem is well defined. Okay, so a good problem solvers are those who first fully understand what the problem is. Step 3, research and preparation. So what you need to do is collect useful information, okay, search to determine if a product already exists, okay, or perhaps you could adapt or modify existing components. And last, you have to review and organize the information collected in a suitable manner. Then we have the step 4, conceptualization. Okay, you have to generate ideas or concepts that could offer reasonable solutions to your problems. Then we have step 5, synthesis. So at this point, you begin to consider details. So what you need to do is perform calculations, run computer models, narrow down the types of material to be used, size the components of the system, and answer questions about how the product is going to be fabricated. And of course, you need to consult pertinent codes and standard for compliance. Then we have step 6, evaluation. Okay, so you need to analyze the problem in more detail. Okay, you have to identify critical design parameters and consider their influence in your final design. Always make sure that all calculations are performed correctly. So the best solution must be identified from your alternatives. Step 7, we have the optimization, minimization, or maximization. Okay. Optimization is based on some particular criterion such as cost, strength, size, weight, reliability, noise, or performance. Optimizing individual components of an engineering system does not necessarily lead to an optimized system. So here is an example of optimization procedure. First, of course, you have to have your initial design. Once you have your initial design, you have to perform the analysis. Okay. After that, you have to evaluate the result of your analysis. And then here we'll have two options. Okay. Can the design be improved? You have two options. Okay. It's either yes or no. If yes, you'll have an option to modify your design again. Okay. Once you modify your design, you'll go back again to performing the analysis, evaluate again the result of the analysis, and then again answer the question, can the design be improved? Okay, now if no, that will be your now the final design. Now number 8, we have the presentation. Okay, so we are all familiar with presentation. Okay. Here you need to communicate your solution to the client, who may be your boss or another group within your company or an outside customer. Okay, so engineers are required to give oral and progress reports on regular basis to various groups. Okay. Consequently, presentation could well be an integral part of many other design steps. So other engineering design considerations. So we have the engineering economics, material selection, teamwork, conflicts resolution, project scheduling and task chart, evaluating alternatives, patent, trademark, and copyright, engineering standards and codes. Okay, let's start with the engineering economics. So economic factors always play important roles in engineering design decision making. Okay, example of products that are too expensive cannot be sold at a price that consumers can afford and still be profitable to the company. Okay, so products must be designed to provide service, not only to make our lives better, but also to make good profits for the manufacturer. Material selection. Okay, so selection of materials is an important design decision. Example of properties to consider when selecting materials. We have the density, ultimate strength, flexibility, machinability, durability, thermal expansion, electrical and thermal conductivity, and last, resistance to corrosion. Okay, let's move to the common traits of a good teams. Okay, successful teams have the following components. The project that is assigned to a team must have clear and realistic goals. Okay, these goals must be understood and accepted by all members of the team. So the team should be made up of individuals with complementary expertise, okay? Problem-solving skills, background, and talent. Of course, the last one, the team must have a good leader. So conflicts. So when a group of people work together, okay, conflicts sometimes arise. Okay. So conflicts could be the result of miscommunication, personal differences or personality differences, and the way events and actions are interpreted by a member of a team. So of course, to resolve the conflicts, we have the conflict resolution. Okay, managing conflicts is an important part of a team dynamic. So in managing conflicts, it is important to recognize there are three types of people. First, we have the accommodating. Okay, it allows assertive individuals to dominate. Okay, actually making progress as a whole is difficult, and it could lead to poor team decision. The next one is the compromising. Okay, it demonstrates a moderate level of assertiveness and cooperation. So by compromising, the team may have sacrificed the best solution for the sake of group unity. And the last one, we have collaborative. Okay. So they have high level of assertiveness and cooperation by the team. Okay, and they don't have any finger pointing. Okay, the team proposes solution and they have means of evaluation. They also combine solutions to reach an ideal solution. Next, we have the project scheduling and task. Okay, this is a process that engineering managers use to ensure that a project is completed on time and within the allocated budget. So you will notice here, you have your task. We have different tasks: research and preparation, progress reports, concept development, synthesis and evaluation, fabrication, testing, optimization, preparing the written and oral reports, and of course, the last one is the final presentation. You will notice on the personnel, it was assigned to a specific person. Example, research and preparation is assigned to Jim and Julie, okay, and this is the time frame. Then we have the progress report, which is assigned to Lisa. Okay, so again, you have your time frame. Okay, and you will notice on the final presentation, it was assigned to all the personnel, Jim, Julie, and Lisa, and they are expected to present the final presentation on the week 13. So we have now sustainability in design. So sustainability and sustainable engineering can be defined as design and development that meets the needs of the present without compromising the ability of future generations to meet their own needs. Again, design and development that meets the needs of the present without compromising the ability of future generations to meet their own needs. Okay. Actually, engineers, they contribute to both private and public sectors of our society. So in private sector, they design and produce the goods and services that we use in our daily lives to allow us to enjoy a high standard of living. Okay, in public sectors, they support local, state, and federal missions such as meeting our infrastructure need, energy and food security, and national defense. So for future engineers are expected to design and provide goods, okay, and services that increase the standard of living and advance healthcare, okay, while addressing, of course, the serious environmental and sustainability concerns. Okay, so always remember in designing products and services, engineers must consider the link among the Earth's finite resources. Okay, we have the environmental, social, ethical, technical, and of course, the economical factors. Okay, that's all for my discussion today, class. Thank you and have a nice day.